Hello and welcome to today's session. This is basically going to be a recap of what transpired in yesterday's session. So today, uh, I'm re-recording what should have been yesterday's session. Yesterday we got a bit of technical issues and we were unable to get a good video at the end. So one of the videos didn't have audio to it, and then another one failed to save. So on my side the video failed to save because my system went into a read only in the middle of the presentation, and I was unable to access the terminal to override the system and make it and put it back to read read and write. So uh, that is why I'm making this again. So for those of you that weren't here with us, yesterday we looked at the event loops and we looked at what they are and how they actually work. We started off the session by looking at an overview of what JavaScript is, how JavaScript code works, and a few concepts that you have to understand before you get to know how event loops work. So to start off, JavaScript is basically a programming language that was created for sole purpose of increasing interactivity to the web pages and also to create dynamic websites. So to dive into a little bit of technical definition of what JavaScript is a single-threaded programming language, and what that means is that it can only execute one task at a time. So if you have a bunch of operations that you want to do, or a bunch of tasks that you have to do, so it has to execute one task at a time. And JavaScript is also a synchronous language, and by synchronous we mean that execution of one task is entirely dependent on the successful execution of the previous task. So if you have these tasks like this, task 2 cannot execute before task 1 completes. So basically that is what what synchronous means in a nutshell. So operation 1 has to first finish, and then we can go ahead and execute task 2. That is what it means to be synchronous. However, JavaScript has asynchronous capabilities as well, as we are going to see in this video, whereby if, let's say, task 2 is going to take a really long time to process, what JavaScript does behind the scenes is that it puts that executing function somewhere and lets operation 3 to go to carry on, and lets operation 4 to carry on, and after that, that is when it would go back to operation 2, as we are going to see. So whenever you start a JavaScript program, what happens is that it creates a thread of execution, and this thread of execution has two parts to it. It has what we call the call stack, and it also has what we call the memory heap. So the call stack is where your code executes, your functions execute, and then the memory heap is what keeps references to the variables and the functions in your code. So to have a visual look on what on how a stack actually how the call stack actually looks, this is our call stack, and it is basically a stack of functions, so one on top of the other, and it operates in a manner that we call last in first out. What that means is that the last function to be put on top of the stack is the first function to be popped off the stack. So that is how the call stack looks like. So you can think of it as books stacked on top of each other. So the book that is at the very top is the one that is easiest to remove from the stack. And another visual representation of this is up here we have this code, and basically what it does is we have three functions. Each of them prints a value onto the console. So when we go ahead and invoke these functions in order. The first function is going to be put onto the stack, executed, and then it is popped off the stack, and that is what happens. And in cases where we have the first function invoking the second function invoking the third function, that is when we end up with this kind of stack. So to show you a visual representation of that in real code, so here I have the same exact code, and when I run this code onto the terminal, we can see that it logs first, it logs second, it logs third, and this is the order that we expect the print statements to be in. So to show you the code stack, I will need to run a debugger so that we can go through this code step by step. So when I run the debugger, okay, so I have to add some breakpoints here. Okay, so when I run this code, what happens is a global execution context is going to be created, as you can see, and also the function references are also created. So here we have the first function, here we have the second function, here we have the third function, and then down here we have the call stack. So this is our call stack. So this call stack, so I post the code execution on line 13. So if I'm to step into the function, if I start to execute the function 13, what happens is the function that is on line 13, the first function, what happens is this function gets pushed onto the call stack, as you can see. So global.first. Remember I told you, so when we go back to this, how the call stack looks like, it has what we call the global execution function at the very bottom. So yesterday at the end of the session, someone asked what the global execution context is, and it is basically an environment that is created when you run a JavaScript program, and its purpose is to keep create the memory which keeps the variables and also keeps track of the function references. So when the code runs and these the functions are added to this global context, and that is why here the first function is referred to by global.first. So the first function is put onto the stack, and then when I execute the code, so this is where we are. So we are executing the first function. When I execute the code, it logs first, and what happens after it logs first is that this function is popped off the stack. So we no longer have global.first here, we no longer have the first function here. So the same thing happens when I go to line 14 and execute the second function. So as you can see, it has been put onto the stack. So when I run the console, it logs onto, and then after that the second function gets popped off the stack. So that is what happens. So we have times where we have to call one function, calling another function, just like in this illustration. So the first function calls the second function calls the third function, and that is where we end up having a stack like this. So this is This is what I want to illustrate for you here. So what happens is, if this first function calls the second function calls the third function, so this is where we are going to end up having a stack of functions, so functions that are stacked on top of each other. So if I'm to oops so back to our debugger, so if I'm to run this code one more time, what happens is that so I had to I have to detach and then stop, and then I need to run this again. Okay, so when we run the code, what happens is, as you can see, the code stack is empty right now. It only has the execution context, and when I step into the function, what happens is the very first console print statement is going to be executed, and as you can see, it logs the very first oops so I forgot to add a breakpoint here and a breakpoint here, yeah, so that we could visualize this. So one more time, I'm going to run the debugger, and we are going to see this in action. So when we run the code, so we see the first function has been put onto the stack. So the more I go into the function, what happens is that it is going to invoke the second function down here, and when it invokes the second function gets added onto the call stack, on top of the call stack, and then the second function is going to print onto the console, and after that it is going to invoke the third function. So the third function also gets pushed onto the top of the stack. So this here is what we have right here. So after the code in the third function runs, after the console.log on the third function runs, what happens is that it gets popped off the call stack, and only it gets popped off the call stack, and only after then that the second function also gets popped off the stack, and then the first function also gets popped off the stack. So you get it. So that is the call stack. That is the call stack. So the last function to be invoked is the first function that gets off the call stack. So in cases where we have this is a sample code that basically invokes the greet function and the respond function. So the respond function, if you look at it closely, it returns a set timeout. The set timeout is not a function that is natively provided to you by the JavaScript engine or the JavaScript environment, but it is provided to us by the web API or the C++ API, and basically what it does is it allows us to delay execution of code without blocking the main thread. So when we run this code, the output that we would expect is that the hello is going to come, and then after that we call the respond function. So the respond function has the set timeout, and like I told you, the set timeout is provided to us by a web API if you are running the code in the browser, and if you're running it in the Node.js environment, it is provided to you by the C++ API. So that means that when the respond function returns when the respond function returns the set timeout, what happens is that the callback of that set timeout is handled by the web API. So comes onto the stack, the respond function comes onto the stack, comes onto the call stack, and then it calls upon the set timeout, and the set timeout is handled by an external web API that is not part of the JavaScript engine. So when it gets onto the call stack, what happens is that the timer starts to run. So once the timer is done, this callback is put or is pushed onto the queue, and then it has to wait until the call stack is empty so that it can now run, its code can now run. So this is how it basically looks, and this is where the concept of the event loop comes in. So the event loop constantly checks the call stack whether it is empty and it doesn't have any code running at the moment. If it is empty, that is when it checks the callback queue. If there is anything on the callback queue, it now pushes it onto the call stack. So that is the event loop. So to give so what happens is if we have an external API that is called, for example, the set timeout, the set timeout will send its callback onto the web API that handles it. After that, after the given duration, it is then pushed onto the callback queue, and then the callback queue will now push it back onto the call stack, and that is when we would see the outcome. So this was a mini quiz that I gave to the participants that were in yesterday, and one of them actually attempted it and passed it. So following the same basic concept, so we have three functions, and we first evoke bar, which is this function that is here, and then you realize that its return value is a set timeout, and remember the set timeout is not natively provided by the JavaScript engine, therefore it has to be handled elsewhere. So in this case, so if I'm to run this this code in my VS Code, you will realize that it is for my case it will be handled by the so I think I will need this for one more illustration. So I'm just going to have the functions, but I will not evoke the functions, and I need to take these breakpoints off and this off. Okay, so temporarily I'm going to detach the debugger. So we have const foo, and that console.log fast. Okay, so for this case it will I'll just use foo. Okay, so I'll use first, and then I have const bar, which basically returns a set timeout, set timeout that has a callback. So that has a callback second, and it occurs after a duration of 5 milliseconds. And lastly we have buzz, which returns. Then we have buzz, which returns console.log third. So for this example, I'm just going to, okay, then here we have bar, then we have for or full, then we have bars. Then we have bars. So we have evoked each of these functions, and when we run this code, what is going to happen is we are going to get first, third, second. Why? And why does that happen when we actually call bar first? Because bar has to return so this can't get any smaller. So remember, bar has to print second, and then for prints first. So since we are evoking bar first, we would expect that we get the second first printed onto the console first, and then we have full printed, and then we have first printed second. So what we expected was, or what you would expect, is an outcome that looks like this, but instead we got an outcome that looks like first, third, and then second. Why is that? So what happens is that if I'm to put breakpoints here to break it down, so what happens is that when we run this code, we go into the bar function. So the bar gets added onto the call stack, as you can see here. So we have bar down here has been pushed onto the call stack, and then when we run the set timeout, what is going to happen is, remember we said that the set timeout is handled by either the web API or the C++ API, which is not part of the JavaScript engine. So that means that the bar function is going to be popped off the stack, and then its callback is going to be handled, its execution is going to be handled by the C++ API or the web API, and then once it gets there, the timer starts to tick. So it's going to be there for a duration of 5 milliseconds. 5 milliseconds, which is about half a second. But remember, the set timeout, we say that the set timeout requires us enables us to delay execution of the code for a given period of time without actually blocking execution of the code, without blocking the main thread. So that means that we would now go ahead and execute the full function, which prints first onto the console, and then after it prints first, it gets popped off the stack, and then we go on to the next function, which is buzz. So buzz has to print third onto the console. So when we go ahead, it prints third onto the console, and then after that it is popped off the stack. It is popped off. It is popped off the stack, so it has printed third. It hasn't completed its full execution, so after it completes, it gets popped off the stack, and only we shall see the bars. We shall see the second. We shall see second being printed onto the console. Why? Because now the cold stack is empty. It doesn't really have anything onto it. So that is where the event loop comes in. So the event loop will check whether the cold stack is empty, and it then sends our callback onto the cold stack. So I hope that demystifies the event loop for you. So where you've not understood, I will be very happy to provide you with a one-on-one so that you can understand this important concept of JavaScript. So in this complete illustration up here, we have the JavaScript engine, and remember we said that every time you run JavaScript code, we have a thread of execution that is created, and to it we have a cold stack and a memory heap. So these keep in sync. So the memory heap keeps track of the variables and also track of the function references. The cold stack executes your code, and then for functions that are provided to us by the web API or the C++ programs, such as set timeout, set interval, read file. So all of those API are provided by these APIs. So the callbacks are handled by, or that timer is handled by the web API. After that, after the timer goes off, after the 5 millisecond or after a given duration of time, it is sent, the callback is sent onto the callback queue, and then in the callback queue it has to wait until everything on the call stack, all the functions that are on the main thread have executed and the call stack is empty, and then the event loop sends the callback onto the stack to run the code, and that is why we ended up with this output. That is why we ended up with first, third, second. So even if we actually make this a zero duration, still the same thing would happen behind the scenes. So when I run this code one more time, so let me take this off. So when I run this code one more time, what happens is we see down here that it is first, third, second. Nevertheless, we used 0 milliseconds. So that was yesterday's presentation, and thank you. So these are the resources that I used to come up with these illustrations, so you can feel free to go and check these resources out. They are very good, and if you want to read more about it, you can use these resources. Thank you and have a nice time.